Final section from Quadratics is all about modelling. So what I mean by modelling is when we use a mathematical model to represent a real life situation. They can vary from very simple ones to extremely complicated ones, and the solutions can be approximate or exact. Quadratic functions are often used to model projectile motion because of the shape of them. The parabola is an excellent approximation for how something flies through the air. So this first example is like that: a sphere being thrown over level ground from the top of a tower. This function represents the height of the sphere after t seconds have passed. So t is greater than or equal to 0. 0 is when the sphere is thrown, and t is the time after that. This is a common question. Interpret the meaning of one of the values within the function, usually the constant term. In this case, what does this 12.25 represent? Well, this is the y-intercept. If t is 0, these things disappear. So this is the value of h when t is 0, i.e. the value of h right at the start. So it is the initial height of the sphere above the ground. In other words, it's the height of the tower. Part B, after how many seconds does the sphere hit the ground? Well, when it's hitting the ground, its height above the ground is 0. So we work out this by working out when is h equal to 0. What value of t gives us a height of 0? So we need to make this quadratic equal to 0. 12.25 plus 14.17 minus 4.90 squared equals 0. So you can just put that in your calculators. With A equal to minus 4.9, B 14.7, C 12.25. Your calculator will give you an answer 3.68. So 3 significant figures. So that's when the sphere hits the ground. It'll give you another value as well, a negative, but we discount that because t has to be positive. It's time from 0 onwards. Another common question: change this quadratic into this form. So if you look at this, you should recognize the completing the square form. Just slightly rearrange. The constant term is before rather than afterwards. So it wants us to write it in this form, so you should aim to get it in exactly this form. But it is just completing the square. So I would start by factorising the 4.9 to give me a t squared on its own in the bracket. Dividing 14.7 by 4.9 is 3. 12.25. It remains the same for now. Then we do the completing the square step. Halving that term in the bracket. Halving that. Squaring. So now if we square this, we get 9 over 4 times by this, and we get negative 441 over 40. So we need to add 441 over 40 and 12.25. Combining these two together gives us 931 over 40, and to put it in the form we're asked for, we need the constant part first. So this becomes 931 over 40 minus 4.9 t minus 3 over 2 squared. This is now in the form we were asked for. A, B, and C are constants to be found. We found them, but we could state what they are. A is 931 over 40. B is negative 4.9. And C is 3 over 2. It's not negative 3 over 2, because the negative is already in there. In fact, that's the same for B. So I shouldn't have that. Finally, part D. Using this answer from part C, or another method if you prefer, we can find the maximum height of the sphere above the ground, and the time that this happens. Now, if you remember from sketching, to find our maximum values, we complete the square, which is the process we've just gone through. So we can get from this, our maximum height occurs when the bracket is 0, this becomes 0, this becomes 0, we're left with this. So our max height is the constant term, 931 over 40, which, the three significant figures, is 23.3 meters. The time at which this occurs is when this bracket is equal to 0. So it reaches that height. – 1.5 seconds. Next question. Regards a football stadium with 25,000 seats. The football club has, from past experience, it knows that from 10,000 tickets will be sold if the ticket costs £30. And they should sell 1,000 more every time the price goes down by £1. We're given that the number of tickets sold can be modelled by this equation. T equals m minus 1,000p, p being the price of the ticket, and m some constant, and we need to find the value of m. We do that using the initial information given. So we'll start from that equation. And we are told that they will sell 10,000 tickets when the price is £30 per ticket. So this will give us 30,000. Add that to the other side. And we found M. Some more information given next about total revenue, denoted by R. You would calculate your total revenue by multiplying the number of tickets sold by the price of the ticket. So we had the number of tickets sold here, times that by the price of a ticket, gives us our total revenue. And as with the previous example, we need to now express that in this form. So I would start by expanding that. That gives us a quadratic. We know what m is. I want to complete the square on this, so first of all I would factorise this coefficient of the squared term out. So negative 1,000 lots of p squared minus 40p. Complete the square on this now, halving that term. $20 squared is 400, times by this negative 1,000 is negative 400,000, so we would have to add on 400,000. And now I'm just going to rearrange that so it's actually in the form that was asked for. It's 400,000 minus 1,000 p minus 20 squared. So we could then state that A is 400,000, B is 1,000, and C is 20. At C, once again, using the previous answer or another method if you prefer, work out how much they should charge if you want to make the maximum amount. So we're looking for the maximum value once again. So completing the square helps us do that. The maximum value of this occurs when this part of it is 0, so you're subtracting nothing off. So the maximum value would be this, 400,000. So the max revenue of £400,000. And the ticket price. Makes this bracket equal to 0, so P would have to be 20. So ticket price is £20. That's how we do modelling. Common questions, completing the square. If you ask for maximums or minimums, completing the square. Make sure you write things in the form asked for, and if needed, state what the values are. Sometimes you are explicitly asked to state them, so do make sure you do that. So have a try at these questions from exercise 2H. There's a challenge question to go with them. It's optional, but it's always worth challenging yourself. And then the mixed exercise for this chapter can then be attempted since everything's now been covered.